All right, so how do we do LCM? Question number 1. Find the LCM. What do you do? Well, we got 9xy and we got 15x squared. So for the numbers, for the 9 and the 15, we put them in the box, right? We box the numbers, shop the letters, right? Remember the game plan for find an LCM? So you put the 9 and the 15 in the box. You say, what goes into 9 and 15? What little number goes evenly into 9 and 15? 3. 3 goes into 9 3 times. 3 goes into 15 5 times. What goes into 3 and 5? Nothing. So multiply these together. Times, times, times. 9 times 5. 45. So 45 is the number part. I guess we could have guessed that. They all have a 45. 45 is the number part. And what do you do for the letters? You take one of each to the highest power, right? Remember, we're shopping. We go to Target, and we take one toaster, the most expensive toaster. One pair of shoes, the most expensive pair of shoes. So x squared, regular y. A. Highest x, highest y, right? Just one of each, though. One x, one y, highest x, highest y. We don't total the x's. We don't go 1 here and 2 more makes 3. No. We're not totally. I'm not buying all the shoes at Target. I'm buying one pair, the most expensive pair. One toaster, the most expensive toaster, right? All right. Number 2 is a little more challenging, because you got to factor them first, right? So number 2, take the first one and factor it. It's r plus 1, right? Because 1 times 1 multiplies to be 1, adds to be 2, doesn't it? You with me? So that's r plus 1 squared, huh? Right? Identical twins always make second power. The other one, r squared plus 1r. How do you factor that one? Take out an r, GCF. r plus 1, right? That's correct, because if you distributed it, r times r would be r squared, r times 1 would be r. Good? So now it's shopping time. Look at this, look at this. Ready? I've got them factored. Got them all factored. They're ready to go now. Now it's shopping time. You go shopping, you buy one of every variety, one of every type, the highest power one. So I take an r plus 1 squared. I don't take that one and that one. I just take the squared one. And I take the solo r, because that's a different type. There's a solo r and an r plus 1 package, and the highest r plus 1 package is squared. That's higher than regular. That's it. Does that make sense? Answer C. Questions on that? Stop me if you want to talk about it. Otherwise, I'll just keep on moving. Number 3, right triangle. As soon as you read right triangle, you're thinking a squared plus b squared is c squared, right? Pythagorean theorem, anytime they say right triangle. Okay. Now, they say the shorter leg is 90. So, like, the legs are the two sides that hit the right angle. These are the legs. One of them's 90. And then they say the hypotenuse. Which side's the hypotenuse? That's this side, huh? It's the longest side, the side not touching the right angle, the side that's across from the right angle, huh? It's the hypotenuse, and the hypotenuse is 30 longer. What do we always do with 30 more, 30 bigger, 30 further, 30 longer, 30 wider, 30 taller? Add 30. X, add 30. Which means, when you got an x, add 30, what do you also have somewhere else? A plain x. See how that's so predictable? These word problems are just boring you with their predictability now, right? Is that the same thing every time? Right? 30 longer is x plus 30, isn't it? 30 more, 30 bigger than somebody else's x. Now, if you have the 90 and the x switched, that's totally fine. The order on those two doesn't matter. You could swap them. It doesn't matter. When you plug them into the Pythagorean theorem, it doesn't matter which one's first or second. You could go x squared plus 90 squared or 90 squared plus x squared. Doesn't matter. Other side is x plus 30 quantity squared. That's how we say that in math. Quantity, the whole quantity is squared. Okay, good. There's our equation. Now we just got to solve that thing. So, how are we going to do it? How are we going to solve that thing? 90 squared is 8100. On the other side, square the x, square the 30. Like that. Wrong. But I see that all the time. That is not that. No, 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 no. As I said to my sweet daughters last year, more than 5 times, that's 5 no's. Several times they tried to do that. And every time I would say, no, girls, that's still not true. Still not true. So what do we do? What's not true about that? What we got to do? Got to FOIL it. You got to write the 2 parentheses. Remember, when there's parentheses squared, you got to write 2 of them. You watch out. So I make a big deal out of that, and I do all that to help you because I see so many people. I'm trying to serve you there. So many people make that mistake. So I make a big deal out of it so you won't, I hope. But I know it's easy to make. It just looks like that, doesn't it? But it's not true. You got to write 2 of the parentheses and then FOIL it to get it correct. So then the x one goes to both. That's going to be x squared plus 30x plus 30x plus 900. And the other side is x squared plus 8100. We good to there? So when I FOIL this side out, it's x squared plus 30x plus 30x plus 900. We good? And so that's x squared plus 60x plus 900. Kind of running out of room there. Have to come up here. So up here we go. X squared plus 8100 is x squared plus 60x plus 900. Is that good? Everybody good to there? This making sense? Now, what do you do when you have x squared on both sides? You wave bye-bye x squared, right? It's gone. It's going to cancel out. If we just had x squared on one side, that would be the get a 0, all that kind of stuff. But if you have it on both sides, bye-bye, right? They're just gone. When you have it on both sides, you just subtract it from both sides, and it's out of there. So what do we have left? 60x plus 900. So now it's just regular x, huh? It's not x squared anymore. It's just regular x. So that's much easier. We don't have to do the whole 0 factoring because there's no more x squared. It's just regular x, right? So subtract 900 from both sides. What is that? 7,200? Yeah. So 7,200 is 60x. I still need more room. This problem is going forever. I'm ready to be done. I'm ready to be done. All right. One more. Well, I don't know where I'm going to go. Just like out of room. 7,200 is 60x. Last step. Divide by 60. So use calculator. What is that? 120? X is 120. X is 120 on that one. Did you get that one? I know that was not on the Scantron. So this is the way the real exam will work tomorrow. Is I'll organize them though to make it easier instead of kind of hunting around. There'll be 15 in a row, multiple choice, first 15. And then the last 5 will all not be multiple choice, so you won't put them on your Scantron. You'll just do your work on your test and just leave the answers right there. And I'll grade them on your actual test. So I'll be looking for this work and looking for that answer of 120. That is the answer, by the way. Look what they're asking for. How long is the longer leg? The longer leg. Now, you might think, oh, add 30. No, that's not a leg. These are the legs. So they didn't ask for the hypotenuse, did they? If they did, I would need to add 30. They asked for the longer leg. Well, that must be this side. It's the x. It's the 120. It is just x. It's just 120.
So in it, like a right triangle, that's 360, like, no?
Okay, you're thinking of angles versus sides. So we're just talking sides. Any triangle, the angles make 180. But we're not dealing with angles here. 360 is all the way around a full circle. Angles, amount of opening, not side length.
So these just happen to add up to 360? Or is that a coincidence or not?
So you're saying this is 120, and this is 120 plus 30 is 150. 270. Yeah, just a coincidence. Interesting.
Because that's how I figured it out.
Wow, well, you got lucky. That won't always be the case. No, there's no rule like that, right? Because think about it for a second, Kyle. You could take that same triangle and shrink it down, couldn't you? And it'd be the same triangle, but the sides wouldn't add up to 360 anymore. Right? So that, no, it's the angles total 180 inside of a triangle. But the sides, anything. Yeah. All right. So number 4, okay. Mass of a liquid varies directly. There's our buzzword, right? That's what we did today. That's what we did this morning. Varies directly. So as soon as you see varies directly, what do? A over B is C over D, right? Two equal fractions. Good. And so then what do? 125 over 375 equals 27 over x. If you want to write down the units just to make sure, that might be a good idea. I'm putting cubic centimeters over grams, so it's all good. So there we go. Solve for x. Diagonal, diagonal. 125x is 27 times 375. And I don't know what that is. But you do, right, with your calculators? I mean, I know the final answer is going to be something like 9 or something, isn't it? But what's this step right here? No, it's not going to be 9. It's going to be 81. Huh? 10,125? Thank you. And then last step is divide by the 125, and it's 81. 81, D. We all good with that? That was good, right? Varies directly to equal fractions. All right, next one. We're talking area of a rectangle. What's the formula for area of a rectangle? Length times width, base times height, we're going to column. One side times the other. Good. And then it says area 65, so I'll put in for A 65. What does it say about the length? What am I going to do for length? It says length is 8 more than width. L is 8 added to the width, huh? Does that make sense? Length is 8 more. Length equals 8 plus W. So take that and now plug that in for L. And bring down the W. Good, good, good. Now distribute the W. 8W plus W squared. We good to there? So what are we going to do now? Now that W squared has showed up, what's the thought in your mind? Get a 0. Good. Get right. As soon as the sea monster, there it is, W squared has showed up on the sea. When the sea monster rears its ugly head, you think, get a 0. Get a 0, right? As soon, let me write it over here again. So as you see W squared with an equals, or, you know, any letter, X squared with an equals. Step 1, get a 0. Step 2, factor. Step 3, each one equals 0. All right. So we say, okay, got to get a 0. So subtract 65 from both sides. So now we have 0. And I'll reorder this. W squared plus 8W minus 65. So let me write it up here. W squared plus 8w minus 65. Good. Good to there. Factor this thing. So 2 parentheses, w's in the front. Now, it's kind of hard. 65, use your calculator. Take 65 and start dividing by things. Divide by 2, divide by 3, divide by 4. When you divide by 5, you'll get 13. Then you go, oh, that's M. You don't need to mess around anymore. It's 5 and 13. The length and width are 5 and 13. Right? But which one's which? They're asking me to find the width. How do I know which one is width, 5 or 13? Yeah, length is 8 more. So the length is the bigger one. The width is the 5, huh? That good? Remember those? Don't really need to finish the problem once we got that. Is that good? Did you get that one? So those will be on there. No multiple choice to help out. You got to just figure all that out on your own. Show me your work. Usually on this exam, I get a bunch of blank things. And it's 0, 0, 0, 0. And that adds up to 0 with a bunch of zeros. So you don't want that to be you. Don't fool yourself. Don't play games. Don't tell yourself pretty little lies that I'm ready, I'm ready, I'm ready. Oh, really? Check it out. You got to practice it. How'd you do? Are you ready right now? How'd you do? Did you get that problem? Right? This is meant to tell the truth to you. It's speaking to you. Are you listening? It's saying a message. It's speaking truth. It's saying how ready you really are today so that tomorrow's not a surprise, right? What's it saying to you? Are you listening? Are you hearing it speak? So, we good? Make sure you know. Make sure you can read those words and know what that means. Was that a happy yes or kind of a dreadful yes?
I hope I remember this when my kids are older.
Yeah, so to help them out with their algebra stuff. That's
Probably
right.
not, but
If you keep going higher, you will. Yeah, that's always how it is. If you go higher, you remember the easier stuff.
I gotta remember birthdays, social security numbers. It's too much.
I know what you mean. Contractor finds that it takes Sam Tuckett 10 hours to construct a wall of a certain size. It takes Jim Lowell 7 hours. Blah, 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 blah. Working together. What's the formula for working together? Yeah, 1 over A plus 1 over B is 1 over X. Remember that? That's what we always use. So you got to put that in your 3x5 card, unless you got it memorized. 1 over A plus 1 over B is 1 over together, 1 over X. Right? That's what we use for the working together. There'll be one of these on the exam tomorrow. So 1/10 plus 1/7 is 1 over X. Good? So now, what do we do to solve that thing? There's the equation. Now how do we solve it? Common denominator, right? Which is what? 70x. Yeah, we got to use them all, right? Remember, LCD is you use one of each. You're shopping one of each. So you can call it 70x or 7 times 10 times x. Same thing either way. Whatever you prefer. I'm just going to show it all. So I'm just going to go 7, 10x, right? Because that's the LCD. It's one of everything, isn't it? One of every denominator. Top, top, top. Good? Right? Because this is an equal sign problem, right? I'm doing the same thing to the left and the right. All right, now what do? We cross cancel and multiply whatever's left over. So 10 cancels 10. So what's left over right there? 7x. That good? 7 cancels 7. What's left over right there? 10x. X cancels x. What's left over right there? 7 times 10? 70. No more fractions. Everybody see that? Multiply top, top, top by the whole LCD. Every denominator piece. What does that leave us then? 17x is 70. Last step, divide by 17. There we go. If you got that or the decimal, whatever it is, I'm fine with either one on the, questions that don't have multiple choice. I don't care if the decimal fraction, whatever. So I'm happy with any of them. I'm just happy to see the right answer in any form. Questions on that one? Does that make sense?
So do you want us to round it to the nearest hundredth or just
whatever it is.
I don't even care at all.
Okay.
No. I'll probably give you credit even if you round it wrong, as long as it's basically the right answer you get to that point. Okay, so remember that formula, 1 over A plus 1 over B is 1 over X. For working together, there'll be one of those on the test tomorrow. There's one of everything, isn't there? All right, number 7, varies inversely. Varies inversely. What do you do with that? That's A times B is C times D. That's side-by-side multiplication, right? Varies directly as two equal fractions, varies inversely as side-by-sides. So we go, okay, 12 times 5 equals 15 times X. Or C. Yeah, no, it's X. It is X, yeah. 12 times 5 is 15 times X. Everybody see how I came up with that? For varies inversely, you put them side by side, don't you? You just take the first two numbers, 12 and 5, and then 15 and X. So what is that? 60 equal 15X. Bring it over here. 60 is 15X. How do you solve for X? Divide by 15. X is 4. Boom. X is 4. Those are your favorites now, right? So it'll be one varies directly, one varies inversely on the test tomorrow. Are you good? And I keep moving. Number 8's going to be a challenging one, isn't it? Problem this morning, huh? But I guess it's slightly different. Chuck and Dana must be the only people they know. These people, these publishers that write these word questions, because they're using Chuck and Dana again. All right, it's just almost exactly like the quiz. So I'm going to do it quick because I went slower on the quiz one. Distance, rate, time. Chuck, Dana. Chuck's 144 miles. That's Chuck's distance. Dana, 129 miles. The rate, what does it say? Chuck's rate is 5 more. That's the same thing this morning, huh? This is so similar. So I didn't realize that. So then, now how do you get the time boxes? Remember, that's dividing, right? 144 over X plus 5 and 129 over X, right? Then you grab out the two time boxes and you set them equal because it says same time, which means, right? Same length of time, which means equal times. So there we go. Two equal fractions. How do you solve two equal fractions? Diagonal, diagonal, cross multiply. 144x is 129 x plus 5. Distribute. 144x is 129x plus 645. Now x is saying I want to be alone, so that means subtract 129x from both. And you're left with something else, I don't know. 15x equals 645. Last step to get x alone. Divide by 15. X equals, thank you, 43. Now careful, that may be the answer, it may not. That's the key that'll unlock the door to the answer. What are they asking for? What do they want from us? Chuck, at what speed? Yes, the speed for Chuck. Chuck's rate, which is right here. It's that box. Right? It's always one of those 6 boxes, huh? Chuck's rate. So take that 43, put in 43 right there. 43 plus 5 is 48. It's just like the one on the quiz today. A little different numbers, but basically the same thing. 48. That's the answer to that one. Is that okay? Just like it was on the quiz. All right, on to number 9. Number 9's a big complex fraction. We did those at the end of Thursday, right? It's when you guys are at your most focused, at the last day of the week, in the last hour, after 3 hours a day for 12 hours of lecture of math. I went over complex fractions. Did you get those? You got those down? Can I flash to a new screen? Everybody got that? Everybody okay there? All right. So it'd be good to do them here again, one more time. So let me just bring it up here for clarity. I'll bring it up here. So 9 plus 3 over x all over x over 4 plus 1 over 12. Okay. What we do? Fractions over fractions. It's called a complex fraction. We've got to clean it up. Look, it's going to be one of these. It cleans up a lot, doesn't it? So How do you clean it up? What do you do? LCD, like everything on this test, huh? LCD, LCD, LCD. So LCD, you look at all the denominators, all the things under bars, not the 9. He's not under a bar. All the other ones. So we got 4, 12, and x. What's the LCD for 4, 12, and x? 12x, right? If you're not sure about the 4 and the 12, 4 goes into 12. So 12 is the holder. But if you're not sure, put them in a box. 4 goes into 4 once, 4 goes into 12 3 times. Nothing goes into 1 and 3. You're done. 4 times 1 times 3. Sure enough, 12. So 12, and then you got to have the x also. And so what do? You go 12x, 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 12x. All those are really over 1, aren't they? Right? We good? All those are over 1. All right. So now we cross-cancel and multiply leftovers. These guys will just multiply because that 9, again, is not under a bar. It's 9 over 1. So 9 times 12, 108x plus. Here the x is canceled. 3 times 12 is 36. Am I going too fast? See what happened in the top there? Everybody see? Everybody see why? I'm going to stand up on this chair, fall down, and kill myself. Class will be over, though. All right. So 9 times 12. Those are multiplying, right? They're not dividing. Right? Everybody see that? It's a common mistake I get. That 9's not under a bar, so those just multiply, right? 9 times 12. Right? But over here, the x's cancel. Okay. So down below, 4 times 12 is 3. I always feel that when I'm sick, if I'm sick. I'm rarely sick, you've noticed. And you probably wish I was a little sicker, right? I just think it's funny. Because whenever there's a sick note on the door, students are like, yes, Mr. Jones, I think he was in a car accident. He's going to be out for like 2 weeks. Isn't this the greatest thing in the world? I'm just kidding. I know it's not personal at all, but you're just like happy about a day off. Anyway, it's just kind of funny. Cracks me up. All right. Anyway, 3x squared. Everybody good there? 3x squared. Good. See what happened? The 4 went in the 12 3 times, and then there was a couple x's, so x squared plus 12's cancel, x. Everybody see the canceling and the leftover? Now we have another step to go. We can tell it's not yet like any of these answers. Everybody good to there so far? Now, what else can we do? Factor. Yeah, we can factor. Remember, that's how you reduce. You factor. You can't cancel right now. You got to factor. I would take my calculator at this point, if I didn't already know. I would take my calculator and divide that by 36. I go, I wonder if 108 is divisible by 36. Let me try that. And it'll say, yes, sir. Yes, ma'am, it is. 3 times plus 1. You see that? 36 times 3 is 108. And 36 times 1 is just 36. Right? So just try that stuff in your calculator. Down below, what's the GCF of 3x squared and plain x? Just x. Also leaving 3x plus 1, because x times 3x would be 3x squared, x times 1 would be x. And then these would cancel. And you'd have 36 over x, which is none of the above. It's not there, is it? Did you get it? Or maybe you got none of the above without getting the real answer. That can happen. Sometimes none of the above helps you out that way. Questions on that? You okay in the cut? There's going to be two, we'll do the other one. There's going to be 2 complex fractions. This is one of them. It'll be just like this, as far as there'll be one where you don't have to factor, and then there'll be one where you do have to factor, which is coming up. Are you good? I better keep moving. We're not halfway. Okay, I'm going to copy that. I need more room. So 1 over 5x cubed, so number 10. Minus 5 over 10x. All over. 5 over 2x. 5 over 5x cubed. Okay, so there's number 10. So same thing, right? LCD. Top and bottom, what is the LCD? Well, I've got let's do the numbers first. I've got a 5, a 10, a 2, right? It's 10, right? They all go into 10, don't they? If you're not sure, put them in a box. 5 goes into 5 one time, goes into 10 2 times, doesn't go into 2. 2 goes into 2 and 2 one time, bring down the 1. 5 times 2 times 1 times 1, 10. 10 is the number part of the LCD. And then what do you do for all those x's? Right, I'm taking aim at I'm looking at all the denominators, saying what's the common. What do we do for all those x's? Take the highest, right? You're shopping at Target, going to buy one of each type, highest power. So I'm going to take x cubed, 10 x cubed. Question?
Can't you just simplify right now before we know all that?
Yeah, you could. Good observation. Like 5 into 10 and 5 with 5? Yeah. You totally could. You totally could. Yeah, that's an easier way to go too. I'm not going to do it because most people probably didn't notice it. So, but good job. You do that. That'll make it a little bit easier. Yep. So 10 x cubed, 10 x cubed over 1, right? 10 x cubed, 10 x cubed. Everybody gets one, top and bottom. Right? I'm doing the same thing to the top that I am to the bottom. Good. LCD. All right. What do you do now? Cross cancel. Multiply what's left over. X cubed cancels x cubed. 5 goes into 10 2 times. 2 minus. 10 cancels 10. X goes into x cubed, leaving x squared. 5 x squared. Good so far? Two goes into 10 5 times. X cancels in x cubed, leaving x squared. 5 times 5, 25 x squared. Is that too quick? See how there were 2 5s there? Made 25. That okay? And then here, can I move on? We good? That making sense? Everybody see what happened? Right? 2 went into 10 5 times, and the 2 leftover 5s multiplied. And here, 5 goes into 10 2 times, and then the leftover 5 times 2 is 10. X cubes cancel, that's it. There's our answer. Good on that one? Why are we done right now? We can't factor that. I mean, you could take out a 5 in the bottom, but it's going nowhere. It'll be that, and that doesn't cancel with the top. You might think, well, that's almost the same as the top. It's not. It's a minus. That middle minus versus plus is totally different. You can't just turn that around. It'd still be minus in the middle, right? It's not the same as the bottom. Can't cancel, so don't even bother with this. Just leave it as it is. Is that okay on that one? Questions on that one? All right, I'm going to move on. Okay, number 11. Number 11 is a divide problem, isn't it? It says divide. It's hard to see the symbol, but it says the word. So that means you flip the one on the right, don't you? So you got to flip the one on the right, change to times in the middle. Keep the one on the left the same. So times in the middle, keep the one on the left the same. Okay, what does that do? Well, now you got to factor everybody. So x plus 3, x plus 5 over x plus 3 times, factor out a 3, the bottom, x plus 5, x minus 5, right? And then start canceling. X plus 3s, x plus 5s, x minus 5s, all you got left is 3. Good. So flip the one on the right, factor everything, and cancel. I'm going to move on. Number 12. Trying to get. When you get to those last ones, which are hard. 5x plus 2 plus 9 is 1/5. What do we do to solve number 12? What do you do when you got fractions with an equal sign? LCD. That's like every problem almost, right? LCD, LCD. So what's the LCD? 9's not under a bar. 5 and 2 are 10, right? 10's the LCD. Multiply through 10. 10, 10, right? Oh, these are over 1. Over 1, over 1. So cross cancel. So 2 goes into 10 5 times, so that's 25x. 9 times 10 is 90. 5 goes into 10 2 times equals 2. We good? 25x plus 90 equals 2. How do we solve for x? Subtract 90 from both sides. So I'm running out of room. I'm going to bring it up here. So we have 25x is minus 88, right? 2 minus 90. Last step, divide by the 25. There it is. A minus 88 25ths. Good on that one? Okay, if I move on. These are all written out for you online on the practice exam as well. All right, I'm going to move on from there. If you've got that down okay. So number 13, got to factor. You got to begin by factoring. So 4 over x minus 4 plus 1 over 2. Factor out a 2. Everybody see that, what I just did? Factored out a 2 from that 2x minus 8. Factor out a 2. Now, multiply through by the common denominator. And what is the common denominator? Well, you need one of each. You need a 2 and an x minus 4, a 2 and an x minus 4, a 2 and an x minus 4. Common denominator. Right on through. Right? One of each, right? Common denominator is one of everything. One of each variety, each type. Top, top, top. 2x minus 4, 2x minus 4, 2x minus 4. Cross cancel. Whatever's left over, you multiply. So 4 times 2, 8. Am I going too quick? Is that okay? And here, the total 2x minus 4's cancel, it's just 1. Here, the 2's cancel, it's 9 times x minus 4. Much nicer, no fractions. Everybody see that? First, most important step. Multiply through by the LCD. Eight and 1 is 9. Distribute here. 9x minus 36. Finish getting x alone. Add 36 to both sides. What's that? 45 equals 9x. Last step to get x alone. Divide by 9. X is 5. Questions on that one? We good? I flash off that. You got that down okay? Here, before I run out of time. So, number 14, okay. It's a bunch of factoring. So, it's this time, so I'm just going to factor. X plus 2, x minus 2 times... This is what? I don't know. Minus 2 minus 3. Kind of getting scribbly there. Over x times x minus 3. Yeah. Right? See how I factored everything? Right? The two negatives. Negative 2 times negative 3 makes plus 6. They multiply to be plus 6. And they add to be minus 5, right? Minus 2 and minus 3. So it's all factored correctly. It's just times. So you don't need common denominator or anything like that, huh? Everybody with me? No common denominator needed, huh? Not required. When do you need common denominators? When you add or subtract fractions, huh? This is just multiplying fractions. This is just factor and cancel. So x minus 2, x minus 2, x minus 3, x minus 3. Anything else cancel? Everybody see that? Everybody see this 1x will cancel, leaving 1x on the top. So we're left with x on the top, x plus 2 on the bottom, right? C. Good. Let's do number 15. Number 15, 3z cubed over 4 times 20 over z squared. What do? You just cross cancel, huh? Just cross cancel and multiply what's left over. Again, the multiplied ones are easy. They're just factor if necessary and cancel away. Cross cancel, right? So 4, I'll change my color. 4 goes into 20 5 times. And z squared goes in, leaving z to the first. Is that good? Multiply what's left over. 3 times 5, 15, z, just z to the first. 15z. C. See the options, the answer is always C. Has been for a while here. If in doubt, just choose C. No. Good there. Questions on that? Now it's going to pick up at 16. You ready? Ready to go to the ugly stuff. Last 5. All right. So 16. Let me rewrite it here. 6x plus 4y over 5x squared y minus 2x minus 3y over xy squared. Never what? I know I say a lot of things.
Subtract.
Good. Nice. Good memory. Never subtract. I know I say a lot of things, but that is an important one. Never subtract. Never subtract. What am I talking about? Never. What do you do? It's subtraction. What do you mean don't subtract? It's a subtraction problem. What do you do? Distribute. Distribute the minus to the upper right. Change signs and add, right? That minus goes to the, remember we never split. That's, if I was to make a top 10 list of most common mistakes in this class, probably in all of algebra, that would be number 1 on the charts. It's so easy to forget that minus sign buried way back there when you get all this LCD junk going on everywhere. Don't try it. Don't subtract. It's hazardous to your algebraic health. Never subtract. Instead, you let that minus sign go. Boom, boom. It'll be minus 2x plus 3y, and you just leave plus in the middle. Instead of subtracting, you're adding the opposite. Does that make sense? Same effect, but way better chances that you won't forget the minus signs. Everybody see what happened there? So always let the minus signs travel to the upper right, changing all the signs, and there's no more minus in the middle because he's left the middle to go to the upper right, so there's nothing in the middle, which means plus, right? So that's what we are. We never subtract. All right, the rest is normal. So now we have 6x plus 4y over 5x squared y plus minus 2x plus 3y over xy squared. Okay, so what are we supposed to do now? Should we look at the common denominator and say, okay, look at this, common denominator, 5, x squared, y squared, right? 5x squared, y squared, 5x squared, y squared, cross cancel, no. That's illegal procedure. The math cops will pull you over. That's not legal. Why not? Now, you might have got the right answer on this one doing that because you kind of do a little fudge trick in the end, which is neither logical nor correct, but you can kind of force the right answer. But we don't want to do that, right? You won't learn the stuff well, and you'll forget it later if you don't really get it. So why is that wrong? Isn't that what we've been doing? Haven't we done that like 6 times in the last hour? Yes. Are you dialing in the way she's dialing in with truth? Not just imitating steps. but really getting why we're doing what we're doing, it'll work so much better for you. We don't have an equal sign here. There's no equal sign. So what? Well, in math, we're keeping the balance. Remember, there's two ways you keep the balance. Top, bottom, or left, right. Which one's this? Is this a top, bottom, or a right, left? Well, how do you know? Well, there's only one way you can keep left, right. You got to have an equal sign. Only when you have an equal sign can you say left and right. The left equals the right. Right? If two things are equal and you do the same to both of them, they'll still be equal afterwards, right? That's only with an equal sign that you can do left, right. If you don't have an equal sign, like we do not have an equal sign in number 16, then you can't do just the top. That would be illegal. I would change them, right? You have to do the same thing to the top that you do to the bottom. Because you say, well, I'm just doing left, right. You can't. There's no equal sign there. You can't do left, right. Everybody see that? See the two different things we do? If you look back, see this one, right? Well, I guess I got to go back 2 pages. 2 pages. This had an equal sign. From the very beginning, he had an equal sign. He had a left and a right. So I didn't do anything with a bottom. I just put 2x minus 4, 2x minus 4, 2x minus 4. Only the top. Why only the top? Because I'm not thinking about top, bottom. I got an equal sign. The left equals the right. If they're equal before, I treat them the same. I can multiply by 1,000,000 if I want to. I multiply them all by 1,000,000. If they were equal before, they'll be equal afterwards. 1,000,000 times as big, but still equal. Right? Get the idea? Get the logic? If the left equals the right, you're just doing left, right. You don't care about the bottom. But here, I have no equal sign. I'm not doing left, right. I'm doing top, bottom. So what does that mean? What are you doing? These are the kind where you look at your neighbors and you give them what they're missing. Right? Top, bottom. Remember that whole thing? I got to go to this guy and say, what is he missing that the other neighbors have? He's missing a y. And what is this guy missing that the other neighbors have? A 5 and an x. Do you see that? Now, see how that's top, bottom? That's same thing, top, bottom. Same thing, top, bottom. Because I don't have an equal sign. I can't do left, right here. I got to do top, bottom. That way I'm not changing these fractions. Do you see that? Not making sense? See now, see what the bottom is going to be now? 5x squared y times y. That's going to be 5x squared y squared. Both of them are. Look at that. They're both 5x squared y squared. We made them the same, didn't we? We made the denominators identical, right? Does everybody see that? Spend time going over that. You can learn this. All right, so distribute the y. And the top, just put it together, like terms, finish it up. 6xy plus 4y squared plus, see what's happening over here, 5x, boom, boom. That'd be minus 10x squared plus, what's that, 15xy. For that one, I think we can put together like terms. What, 6xy and 15xy would be what, 21xy and 4y squared minus 10x squared. It doesn't matter what order they're in. Over 5x squared y squared. Is it A? I think it's A, isn't it? Just a different order. Yeah, it's A. Done. Does everybody make sense out of that? Is that good? Questions on that one? Oh, look at the time. We good? I'm going to have to move ahead. So remember, no equal sign, top, bottom. Equal sign, left, right. All right. All right, 17. So 25b squared plus 30b minus 4 equals 9. So what do we do on this one? We got b squared. What does that mean? It's the C monster. Get a 0, right? Whenever you got that, whenever, again, I'll write it. When you have a b squared with an equal sign, step 1, get a 0. Step 2, factor, you know, with the parentheses. Step 3, each one gets their own 0. Right? That's always the game plan when you see b squared. So I got to add 12 to both sides. So I got 25b squared plus 30b plus 8 equals 0. I got a 0 on the right side. Good. And now factor. How do you factor? This is FOIL. There's nothing in common. What's in common? No, is nothing. 5 goes to 25, but doesn't go into 8. So factor 5b, 5b. Front times front to be front. Good. 5 times 5 is 25. What times what is 8? Well, 4 and 2. Or 2 and 4. Doesn't matter. They're both with a 5. is that right factoring? Yeah, check the OI, the 2 inner, 20b, the 2 outer, 10b. Do they make the middle term 30b, the middle right here? Yeah, they do. Both plus, they make 30b. That's correct factoring. Everybody good with that? See how the OI, the OI, inner, outer, the 2 inner make 20b, the 2 outer make 10b. That makes the middle 30b. Good, what do you do now? Set each one equal to 0 separately. 5b, the first one equals 0. That's a b there. And then the second one equals 0, and just solve them both, right? Subtract 4. 5b is negative 4 divided by 5. And subtract 2. 5b is minus 2 divided by 5, minus 2/5. We got it. There's the two answers, minus 4/5, minus 2/5. Is that good? Did you like that one? Good with that? I got to move on. Time's wasting and racing. We're close. Finishing the biggest. Whoops, I got the wrong one. Let's try that again. And boom. There we go. Number 18. 60n squared plus 32n. Again, it's the x squared. It's the C monster. It's already got the 0, right? Remember when you got n squared with an equal sign? Same thing. Get a 0. Already got it. Step 2, factor, parentheses. Step 3, each one equals 0. Here we go again. So I'm just going to go right into step 2, factor. You can factor out 4n. Check that in your calculator if you want. Be 15n plus 8. That works. Then you set each one equal to 0. Separately. Like that. And then to solve this one, divide by 4. What's 0 over 4? 0. Subtract 8 from both sides. 15n is minus 8. Divide by 15. There it is. 0 and minus 8/15. See? Again, it's C. Good. We got 2 more. We got 2 minutes. Good to there? Questions on that one? I know I'm racing. So 19. Here we go. All right, first, now we're adding fractions. We've got to factor denominators, right? So this is going to be, what, y minus 2, y minus 1? Right, because that adds to be minus 3, multiplies to be plus 2. You guys good there? Negative times negative, multiplies to be plus 2, adds to be negative 3 in the middle. Good? Plus. And this is y plus 1, y minus 1. Good? So far? Factor them. Now, is there an equal sign here? No equal sign. So no left, right. So what am I going to do? Top, bottom. Right? This is a top-bottom balancer, not a left, right. There's no equal sign here. So this is, what do your neighbors have? So this is y plus 1, y plus 1. And this guy says, what do your neighbors have? Y minus 2, y minus 2. All right, multiply 3. 3y plus 3 plus 5y minus 10. The bottom, you just write it down any order. It's a common denominator. Right? Put it together. In the top here, 3y and 5y is 8y. 3 minus 10 is minus 7. I'm just going to say over the LCD. So what is that? B? One more. Number 20. We good to there on that? See how I did that? Just factor top and bottom, give them what they're missing to make. See how both denominators came out to have the same 3 things? I made the bottoms the same, didn't I? I made common denominators. All right, one more. Yeah. Here it is. Okay. So number 20. X over x squared minus 1 plus 7x over x minus x. Okay, what did we learn to do with this? This right here is a problem, huh? He's out of order. The bigger one's in the back. What do we do? Did I show that way? I show different ways at different times. I don't want to confuse you. Didn't I just reorder them? Or did I multiply top and bottom by minus 1?
Yeah, you reordered them and then you brought out the -1.
Yeah, I did that, didn't I? Did I do both at different times? I'm sorry. Yeah, somebody came up after the last class and they said, which way is it? And I'm like, well, it's either one. Sorry. I should know better. My first year of teaching, when I first taught math, first year, I thought, you know what, I'll show them like 2 or 3 ways to do everything. And they can just make their pick and that'll be easier. And I learned that was not a good, because everybody gets confused. I learned it's better to show one way 10 times in a row. People like that much better. So, sorry. You could multiply top and bottom by minus 1. So now I hear, since I've already shown both ways, I got to remind you could do that. Or I think I showed the rearrange way mainly, didn't I? Did I? Which? Yeah. So rearrange this. This is minus x squared plus x. Right. That's minus x squared plus x. Right. That's just right. Just take the minus with him. He's a plus x, and then factor out the minus x. Right. Minus x squared. Oops. That's going to be minus. See how I just found my own mistake? Even I check them because it's easy to mess up, huh? So make that minus. Now it's right? Because minus times minus will go back to plus, won't it? See that? See what I just did in the bottom there? Everybody okay with that? I reordered, right? Just put the bigger one in the front. Then I factored out what they had in common, negative x. Negative x times x squared, negative times negative, positive. Good, so it's right. It's the same thing. This is just a fancy way of saying the original, right? It's the same thing. Do you see that? So now, let me factor this other one, x plus 1, x minus 1, that's this one, plus, now, 7x over minus x times x minus 1. Am I going too fast? Does that make sense? I want you to be able to see this. Do you see what happened? Everybody see that? I just reordered this original, right? Let's put the minus x squared in the front, the plus x in the back, factored out the negative x. Now, I don't want this minus sign in the bottom. Where can he go? Top. Move him up to the top. Yeah, remember top, bottom's all the same thing. Just get him out of there. Just move him up to the top. Is that okay? See that? Now, it's more regular. Now, is this an equals problem with a left-right or not an equals? It's not an equals, so top, bottom, huh? Top, bottom. All right, come to this guy first. What's he missing that his neighbors have? X. Plain X. What about this guy? What's he missing that his neighbors have? X plus 1. See how they have the same 3 things now? See how I've made common denominator? So x plus 1, x minus 1. Any order, doesn't really matter. Right? Now what's on the top? X times x, x squared. Minus 7x distributes through, minus 7x squared minus 7x. Everybody see that? See what that minus 7x did? As it multiplied the x and the 1. Finally, lastly, 1x squared minus 7x squared is minus 6x squared. Minus 7x over x, x plus 1, x minus 1. Which answer is it? Oh, is it none?
Yeah, because of the factor.
Wait, isn't it D?
Don't you factor out the x?
Oh, you're right. I was going to be wrong. It looks like D. What's wrong? Yeah, there's one more. Sorry, I know we're going over here. One more little step. You could take out that x. See on the top? See how they have x in common? And there's an x down there? Yeah, this thing just won't end. Take an x out of the top. I don't care about the negative or anything else. I'm just taking an x out of the top because that'll cancel with the x on the bottom. Good observation. Those cancel. See that? So there's the answer. That's why it's none of the above, actually. That was a tricky problem. Tricked me. Is that you see that last step? Right? They had x in common. I noticed the x on the bottom and went, oh, factor out the x in common, cancel. So here is the real answer, which is none of the above. Yeah. All right, that's